Hello, welcome back to Learn Physics. In today's topic, we are continuing with our previous year question paper series. In that 2018 we were doing, and in that today we are going to start with the 25th question. So in last video I was not able to complete the 25th question, so I am doing that 25th one. Okay. State the principle of an AC generator and explain its working with the help of a labeled diagram. Obtain the expression for the EMF induced in a coil having N turns, each of cross-sectional area capital letter A, rotating with a constant angular speed omega in a magnetic field directed perpendicular to the axis of rotation. So first one, state the principle of an AC generator. What is the principle of an AC generator? Electromagnetic induction. Whenever the flux linked with the circuit changes, magnetic flux linked with the circuit changes, an EMF is induced in the circuit. That is called a electromagnetic induction. So that is flux linked with the circuit changes and EMF is induced in the coil. Okay, explain its working with the help of a labeled diagram. So here one north pole and south pole, and here this is the coil, and here ends of the coil are connected with the two slip rings S1 and S2, and here we know here two brushes are in touch with that, and here it is connected with the galvanometer. Okay, so this is the axis of the coil. Okay, so this is how we will be representing the what is that? AC generator. So here how whenever we are rotating the coil, what will happen? The flux linked with the circuit changes. So initially it was like this, and next it will be rotating like this, isn't it? So flux number of field lines passing through this, when it comes like this, it will be more. So the flux linked with the circuit is more. Now it is decreasing, now it is very less, isn't it? Minima. So flux linked with the circuit changes and EMF will be inducing in the circuit, and it will be alternating current. How it will be alternating current? Because the direction of the coil is not changing. Okay, and it is given as labeled diagram. So S1 and S2 are the slip rings, B1 and B2 are the brushes, and ABCD is the coil. North N and S represents the poles of a magnet, north pole and the south pole. Okay, so here how flux linked with the circuit? See, we know that phi is equal to B dot A. Okay, so it is BA cos theta. What is theta here? Theta is what is the angular velocity? If omega is the angular velocity for a time t, then theta will be equal to omega t. Okay, so phi we will get it as BA cos omega t. If there are n number of turns in the coil, then the total flux linked with the circuit will be equal to NAB cos omega t. And what will be the EMF induced in the circuit then? EMF induced in the circuit will be minus d phi by dt. As per Faraday's laws of electromagnetic induction, is proportional d phi by the rate of change of flux linked with the circuit, and it will be opposing the direction, minus. Okay, so it will be minus d by dt of NAB cos omega t. So it will be cos omega t is minus sin omega t. So we will get it as NAB sin omega t into omega. So omega NAB into cos sin omega t. This is the EMF induced in the circuit. Find the expression for EMF induced in a coil having n number of turns constant angular speed omega, and A in a magnetic field B. Okay, directed perpendicular to the direction of axis of rotation. So say axis of rotation is perpendicular to the axis of rotation. Magnetic field is directed perpendicular to the axis of rotation. So this is the axis of rotation. Magnetic field is perpendicular to it. So how does what is the value of sine omega t then? Say it is 90 degree. So we will get it as NAB omega. Sine 90 equals 1. Okay, which are both are perpendicular to each other. Okay, then next it is given as an aeroplane is flying horizontally from west to east with a velocity of 900 km per hour. Calculate the potential difference between the ends of its wings having a span of 20 meter. Horizontal component of Earth's magnetic field is 5 into 10 to the power minus 4 Tesla, and the angle of dip is 30 degree. So here that is the second part of this question, B part. Okay, so aeroplane is flying horizontally with a velocity of 900 km per hour. So 900 km per hour. Calculate the potential difference between the ends if the wings are having a distance of 20 meter and the horizontal component of Earth's magnetic field is given as 5 into 10 to the power minus 4 Tesla, and angle of dip is 30 degree. How we can find out the calculate the potential difference? Potential difference is equal to BLV. So here EMF. Potential difference means EMF we can find out. B, how much is the B first? We should find out B. B equals, vertical component will be equal to BH tan theta. Vertical component is equal to horizontal component into tan theta. So it is 5 into 10 to the power minus 4 into tan 30. Tan 30 will be 1 by root 3, right? So E equals B. So 5 into 10 to the power minus 4 into 1 by root 3 into L is 20 and V is 900 km per hour. You should convert it into meter per second. So it is 900 into 5 by 18. So you will get it as 250 meter per second. Here you will get it as 250 meters per second. So you can substitute the value of B. L is 20 meter. B you will be getting it as 250 meter per second. By substituting and multiplying you will get the answer. Okay, clear? So in the 25th question itself an OR question is there. So that one we are going to discuss. A device X is connected across an AC source of voltage V equals V0 sine omega t, and the current through the X is given as I equals I0 sine omega t plus pi by 2. Okay, identify the device X, write the expression for its reactance. So current and the I equals I0 sine omega t plus pi by 2. So it is leading by a factor pi by 2. Current is leading by a factor pi by 2. So what is that X then? It is X is the capacitance. Right, capacitance only will be leading. So if it is an inductor will be having a phase difference of, yes, it will be lagging. Sine omega t minus pi by 2 will be coming if it is an inductor, and resistance mean no phase change. Okay, so here it is leading by a factor pi by 2. So it is capacitance. So this one X will be representing the capacitance of the circuit. X is the device which is a capacitor. So it's not capacitance, capacitor. Device name is capacitor. Write down the expression for its reactance. So what will be the reactance expression? Xc equals 1 by omega C. Okay, this is the representation for reactance. Okay, so omega, instead of omega, if you want, we can write it as 2 pi into nu C. That also we can write down. Draw the graph showing the variation of voltage and current with time over one cycle of AC for X. Okay, so how we can draw the diagram? See, V equals V0 sin omega t. So it is like that we can represent, isn't it? This is 0, this is pi by 2, this is 2 pi by 2, this is 3 pi by 2, this is 2 pi. Okay, this is V. V equals V0 sin omega t. Then I equals I0 sin omega t plus pi by 2. So it will be, yes, it is. So at 0 it will be getting the maximum value. At 90 it will be getting the minimum value. Okay, at 180 it will be getting the maximum negative value. Here 3 by 2 it will be getting the 0 value, and at 2 pi it will be getting the maximum value. Okay, so it won't come till here, so it will be little bit less. Okay, so this is how it will be represented, because V is equal to I into R, it will be less, right? So here it will go like this. It is the maximum value. So this one will be representing the I. Okay, this is representing I, and the other one will be representing this voltage. This is the voltage and current graph. Okay, so next is, how does the reactance of the device X vary with the frequency of AC? Show this variation graphically. How the XC is varying with the frequency? It is inversely 1 by nu. It is varying as 1 by nu. The reactance XC and nu are inversely proportional. So how we can represent XC and nu are inversely proportional. 1 by R means it will be, the graph will be like this. Okay, so next is, draw the phasor diagram for the device X. Okay, now how we can draw the phasor diagram? See here, if this is V, this is I. This will be having a phase angle of 90 degree. Okay, this will be representing I0 and this will be V0. This is representing omega t. This is I0 sin omega t plus pi by 2, and this is V0 sin omega t. Okay, so this is how it will be representing the phasor diagram. Okay, so the next one is 26th question. Draw a ray diagram to show the image formation when the concave mirror produces a real inverted magnified image of an object. So concave mirror, when it is, draw a ray diagram to show the image formation of a concave mirror for real inverted image. So any one position you can choose. Okay, so this is P and this is F and this is C. At any position parallel to it through the principal focus, and if it is through the focus you will be getting an image over here. So we will be getting a real inverted image. Okay, any one position you can choose for that one. Okay, next is, obtain the mirror formula and write down the expression for linear magnification. What is mirror formula? 1 by F equals 1 by V plus 1 by U. This is mirror formula, and linear magnification will be equal to minus V by U. Okay, or we can write it as HI by HO. Okay, this is the magnification. Then explain the advantages of a reflecting telescope over a refracting telescope. Refracting telescope means it will be a wide range of view we will be getting. It will be more clear, resolution will be more, chromatic aberration will be reduced, spherical aberration will be reduced. These are the advantages of using a reflecting telescope. So now one more OR question is there, that is define wave front. So define wavefront using Huygens principle, verify the laws of reflection at a plane surface. This and all direct questions only, no need of explanation I guess, because already we did all these in details in our theory part. Okay, so all these explanations, so mirror formula and the wavefront and Huygens principle, that and all, I'll give that in the description box. If you have any doubt, you can watch that videos and it will be there in the description box. Okay. And in a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of central diffraction band? Okay, so first one, if the width of the slit is made doubled. So width is doubled. So central fringe, how does this affect the central diffraction pattern? So width of central fringe. Width of central maximum. What is the value? 2 lambda d divided by A. So lambda is the wavelength of light which is using and A is the width of the slit. Okay, here how does, if the width of the slit is made doubled, so width of the slit is doubled, so what will happen? The width of the central maximum will reduce to half. Reduce to half. If A equals 2A, if A dash equals 2A, what will happen? Thus A equals to, say new A is 2A. Now then what will happen? Lambda d divided by A it will become, right? So it will reduce to half, and intensity of central diffraction band. What will happen? Intensity will be increasing. If the width is increasing, what will happen? Intensity will be increasing. Intensity of the width will be increasing, but its size will be reducing to half. Okay, so the next one is, when a tiny circular obstacle is placed in the path of light from a distant source, the bright spot is seen at the center of the obstacle. Explain why. Okay, obstacle is there, a bright spot is seen. What is the reason? Because of diffraction. Because central fringe will be maximum, central bright fringe. Isn't it? In the diffraction patterns, we know central fringe will be the maximum intensity, and the sidewise it will be decreasing, isn't it? So here central fringe will be maximum. If an obstacle is there, central, we will be getting a bright maxima. This is due to diffraction of light. Okay, when a tiny, question was like this, when a tiny circular obstacle is placed in the path of light from a distant source, obstacle is there in the path of light, so obviously diffraction will happen. Okay, so clear. So this and all were the questions from this question paper, 2018 question paper. Next day I will be coming with a new series of question paper. So I hope it is useful for you. And one more thing, if you have any suggestions relating to this, please inform me through the comment box. And some of the children told about the NCERT solved examples. You can discuss, and please discuss the NCERT solved examples that is there in my mind also. See, anyway, I'll do that. And what I am planning is for the first chapters, that is first 2-3 chapters that till Kirchhoff's law and all. So those questions I will be explaining. Then I'll again start the question paper series. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.